Hello, it's William, and this is my presentation on differential and cumulative DVH. Um, More specifically, I'm going to be describing what a differential DVH is, transforming that to a cumulative DVH, how to interpret both of them, and more specifically, how to interpret them in regards to prescription dose and OAR constraints. So I'll be referencing some notes and occasionally looking at the screen. Um, and the limitations of these plots is that it doesn't capture where on the organ or the target the dose is landing. And if you want that information, you'd have to look at your isodose maps. Um, the type of plots for these, differential is a histogram. Cumulative is a curve. And how do you go from a histogram to a curve is you integrate. Histograms are bars, and if you multiply height against width, then you can smoothen the curve out with millions or many, many data points. For differential DVH, and you're looking at it for a target, the ideal case is a sharp increase and then a sharp decrease. And for an OAR, it's low heights and low percentage volume across all doses. If the doses can stay narrow, that's really great. But an important takeaway is that you can't look solely at the shape of DVHs to make make a conclusion about the plan because the resolution of these plots are easily easily changed by the user. You can make the resolution really small or big on both the X and Y axes to adjust the aspect of the curve. Moving on to, or well, not moving on yet, but on the differential DVH, you have dose bars, and for each dose bar, you have a volume percentage, and it's saying that that percentage of the volume is receiving that dose. So if you're going to go from that to cumulative DVH, you are doing a summation of the dose bars to the right side of the dose bar of interest. Um, in other words, if you are curious what um, a volume the target receives a minimum of what dose, you would say, or you could say it as like, so 95% of the volume receives at least this dose. But how do you get to that point from a differential DVH? You would um, integrate. And this is usually done by a computer because there are millions of data points, likely millions of data points. And if you wanted to do it on paper, on a differential DVH with just several bars for sake of exercise, um, you would identify your minimum dose of interest and then you sum the volumes um, of all the bars to the right of that dose. Um, and so the more dose bars you have in a range, the more accurate the solution becomes. And for this very reason, it's best done by a computer that will do these operations over and over again. Um, yeah, so interpreting a cumulative DVH, so it's best to start at the limits of everything, right? So you get like a sanity check. You go to zero dose, you see 100% volume. What does that mean? It means even if the machine was never turned on, it's never administering dose, 100% of target volume gets at least a zero dose. And for the same very reason is that if you move towards the right of the plot where the dose is increasing, you should only expect volume percentage to be decreasing, as this is a cumulative effect. And yeah. Um, so what are you looking for in a good plan? It's around 95% of prescription dose, or from 0 to 95% of prescription dose, it's at 100% target volume. You can interpret this as 100% of the target volume receives at least 95% of the target dose. And then you would see a steep decrease from 95% to not more than 105%. And so this is plus minus 5% um, tolerance on your prescription dose, which is typically the tolerance allowable by the prescription. And so even if by the time the slant or the steep hits 0% target volume and it lands at 105% prescription dose, then no volume of your target is receiving greater than 105% of your prescription dose. And this is really important because it ensures we're providing sufficient dose, but we're not overdoing it. With the OARs, the closer they are to the bottom left of the plot, the better. It's low dose to low volume. And because you can't just be looking at the shape of it to make a conclusion, of course, you're going to compare it to the constraints on the OARs and see if you're within the limits to be acceptable. Sometimes, how do you rephrase it? You always try to drive it towards the bottom left of the plot as reasonably possible. And yes, I hope that concludes my presentation. I hope it does help. It was very informative to me, and thank you for watching. So, bye for now.